tackle about the lateral earth pressure. Okay? So what is a lateral earth pressure? What are the types of the lateral earth pressure? And what we consider in designing the lateral earth pressure. Okay? So as we go on to our topic for today, we would be able to understand well this topic about the lateral earth pressure. Okay? So if you have any questions with regards to this topic, no, just raise your hand or post it on our chats, okay? Para hindi naman tayo mga okay? I hope matapos natin ito today, no? Kasi tomorrow, pupunta tayo sa shear strength, okay? Shear strength of your soil using the Mohr circle kasi I included it in your midterm exam, okay? Madali lang naman siya, madali lang naman yung direct shear, no? So, yun. Simple thinking lang naman dun, no? Thinking ability para sa ganun, mas maintindihan nyo later on. Okay? So, yun. Ito, let's watch first. Wait, naririnig nyo ba? Hindi. Hello? Naririnig nyo ba? Okay.
Retaining walls serve the important role of holding back soil and rock, just as dams hold back water. The first video in this series showed that granular materials such as soil and rock generate horizontal pressures that increase linearly with depth. Retaining walls must resist these pressures, and many strategies exist for doing so. In this video, we focus on the popular L-shaped cantilever design. If you were going to use an L-shaped wall to hold back soil and rock, as represented by these marbles, would you point the bottom leg towards the marbles or away from them? Many people would say that the base of the L should face away from the marbles. They probably realize that it is hard to tip the wall over towards the left if the bottom leg points in that direction. In engineering, we call tipping like this overturning. If the bottom leg points the other way around, it is easy to make the wall overturn. So easy, in fact, that I can do it with just a puff of air. It looks like the case is closed. Or is it? Before we declare a final verdict, let's use the model to find out what happens when the bottom leg points to the left away from the marbles. As we add marbles, we discovered that the horizontal forces they produce create yet another mode of failure, namely sliding of the wall. And this occurs when the marbles reach a depth of 3 centimeters. In the model, we can increase the friction between the retaining wall and the base by placing a rubber mat between them. You will have to do some extra reading if you want to find out how they achieve this end in the real world. As you can see, increasing the friction allows our model wall to support a noticeably greater depth of marbles, but it still eventually fails by overturning, in this case, when the depth reaches 8 centimeters. Now let's turn the wall around, so its bottom leg points towards the right, the side where the marbles will be placed. We again use a rubber sheet to prevent sliding, and we add some marbles. As before, the marbles generate a horizontal force that depends on the marble depth. You might be surprised that this wall can hold back 11 centimeters of marbles before it overturns. Can you explain why the wall can resist a greater height of marbles when the bottom leg points towards them? Is there an additional force that comes into play? Recall, the granular materials generate both horizontal and vertical pressures. When the bottom leg is oriented away from the marbles, overturning is resisted only by the weight of the wall itself, and so it overturns easily. When the bottom leg points towards the marbles, the vertical pressure from the marbles helps to keep the wall.
Ayan. Cut ata. Mabilis na cut. So, ayan na. Sorry. What did you learn about the video presentation? Anyone? Anyone from the group? What did you learn from the video? Yes. I think you have an idea. Um, Miss Jonali. Miss Jonali.
Sir, yung sa about sa mga retaining walls, sir. And pinakita sa video, sir, kung ano yung mas magandang pag-facean nung sa base nung cantilever design, sir. Which is yung dapat
Okay.
nag-face siya sa marbles.
Sa marbles. Okay. Another from Joanna. Miss Joanna. You have an idea, I think. Help daw ni Miss Reyes. Mark, ayun lang din ang sagot mo. Tindi mo, Mark, ah. Ayan. So, yun nga. Basically, this video speaks about the situations when we are designing about the lateral earth pressures, no? If we study about the cantilever, no, na nilalagay doon sa mismong sample, no? Uh, where is the best to place, no, yung cantilever, no? And what is the common difference between you add some frictionless, no, na matting, no, and then if you will not input some mattings. Okay, so yun, basically it is just the effect during an at rest, during a active, and during the passive. So what are these three criteria, no, in lateral earth pressure? So as we go on, no, we would be able to understand well what are these three, no, all about. Okay, so yun. So for today, no, our learning objective, no, would be we would know, no, the difference between the passive, active, and at rest lateral earth pressure. Okay, and then we would compute some Rankine's active or passive lateral earth pressure coefficients for our given cohesionless soil. Okay, and then we solve the equivalent. Yes? May ganun ba? Wala na. Okay. And then we will solve the equivalent lateral earth force, no, or passive or active, acting on your wall, no, including the possibility of multiple soils layer, no, water behind the wall, and a surcharge on top of the wall. Okay? So yun. So lateral earth pressure, no, it is the estimation are crucial to structures, no, such as retaining walls, sheet piles walls, buried pipes, basement walls, brace excavations, coffer dams, and others. Okay, but for this topic, no, we would be able to understand the lateral earth pressure, no, in a retaining walls, no, and then later on in sheet piles walls, no, and then in brace excavation, or some people know it as a brace cuts. Okay, so yun, later on your finals, yung dalawa na yun. Okay? So these are the common types of the retaining walls, no, or the sheet pilings, no, na nilalagay, no. So one of the examples is if you go to Tabuk or in some areas, tawag dito tawag dito diyan sa may tawag sa downstream. I don't know kung nakalimutan ko na kung saan downstream 'yan. Na nadadaanan ninyo, but the retaining walls, no, they use concrete retaining walls, no, instead of those um, steel na ganun na retaining walls. Okay, so they are made, no, for the mountains, no, for tawag dito, to lessen the effect of the erosions, no, on the roads, no. And one more thing is here, no, it is the it is placed between the body of water, no, and then to the soil part. Okay, so uh the goal for that, no, is to lessen, no, effects of some floodings, no, and then para ma-lessen din, no, yung pagbaba ng soil dun sa water mismo, okay, para hindi kainin, no, ni water yung si soil. Okay? Kasi the tendency for that, no, baka sasakupin na ni water yung some areas ni soil, no? So to preserve that, no, they place some retaining walls like sheet pilings, no, para sa ganun ay yun nga, para ma-preserve nila yung soils na nandun, okay? But there is a effect, no, ni soil and then ni body of water to that of your sheet piles or retaining walls, okay? And then another example is doon sa 6 line road doon sa may Carig, in front of the Department of Health, no? Going to Baggao ata yun or something like that, no? So at the side, no, they make some retaining walls, no? Um, Maliit yung retaining walls lang. So it is just a typical retaining wall, okay? So yun. So these are the common, no, should I say these are the types of the retaining walls that are being used in some areas. Okay, the first part, no, would be the gravity wall. Okay, it is just a plain concrete, no, or a stone masonry. Okay, so yun, wala silang hinalo na kahit anuman, no, especially the reinforcement, no, just a concrete, no. I think yan lang ata ang nilagay nila doon sa Carig, no. I don't even know kasi hindi ko nadatnan during my OJT kasi umalis kami kaagad doon, no. Just a one day lang kami nag-OJT doon, then lumipat na kami sa diyan sa Pulsar. Okay? The second would be the semi-gravity wall, no? It is just a combination, no, of your gravity wall, no, to that your reinforcement, okay? So kung ano yung size or kung ano yung picture ni gravity wall, no, it is just added, no, you just add some reinforcement, but the placing of your reinforcement, no, it is a slanting L, no, slanting L yung kanya, as you can see in the figure. Okay, and the third one would be the cantilever wall. Cantilever wall is the most popular, no, kasi si cantilever wall, no, it is just a thin, no, thin version of your semi-gravity wall, no. And then instead of the slanting position of your reinforcement, no, kung ano yung mode or kung ano yung itsura ni cantilever wall, no, ay sinusundan na ni vertical na reinforcement mo. And at the bottom, no, of your wall, no, dalawa yung kanyang reinforcement, no. It is placed on both sides. Okay? Para sa ganun, hindi magkaroon ng failure on both sides, no. While on the semi-gravity, may failure na doon sa other part. Okay? For the left part. Okay? And then the last would be the counterfort wall. No? What is the difference of this counterfort wall to your gravity wall or semi-gravity wall or your cantilever wall? Okay? So for counterfort wall, no, as you can see, they provide some counterfort, okay, just to tawag dito, to strengthen your wall, no, and then to provide some supports from the upper wall, no, upper portion of your wall up to the bottom part of your wall or to the soil, no, doon sa mismong baba niya, no. So it is a combination, no, of a reinforcement, no. May reinforcement yan, hindi lang naipakita. And then aside from reinforcement, they provide a counterfort, okay, to just add some additional support. Okay? So, yun. Yun yung nilagay nila. Okay? So, these are the common types, no, of failures kung doon nangyayari doon sa walls na nilalagay natin, no, to support the soil, no. So, if the soil, no, has a more than force than to your retaining wall, no, therefore, sisirain ni soil yung inyong wall, no, or yung inyong retaining walls, okay? And then, that cause an erosion, okay? So, mga yan. So, ano nga ba yung mga different mode of failures and what are these failures, no? Kung ano ba yung kanyang effect or kung ano ba yung kanyang condition, no? When failure comes, okay? So retaining wall. So what are the factors that should be considered when selecting the type of retaining walls, okay? So yun, after this, no, we would be able to understand kung ano yung mga types na pwede natin gamitin, okay? So there is common types, no, of retaining walls that we would be considered, okay? Yun nga yung sabi ko kanina, the gravity wall, no? Si gravity wall, it is a standard wall type, no? And mainly, no, through its own weight, no? So, binubuhat laban ni retaining wall yung kanyang weight mismo. Okay? While on piling wall, no, the piling wall, it is just using long piles, no, instead of a concrete, no, it is a piles na, no. This wall is fixed by the soil, no, on both sides of its lower length. Okay? And then, ang tendency niyan kapag mas malakas yung effect ni soil on the left side, okay, there is a cracking at the lower part. Okay? And then another thing is the cantilever wall, no? So si cantilever wall which may also extend in either in the direction unless no the same earth pressure trying to uh, topple to stabilize, no, itself with a second lever arm. Okay? So, yun kanina yung nakita natin kanina sa video, it is the cantilever wall. Okay? And it's an example of your cantilever wall. Okay? And then there is another type which is the anchored wall, no? Si anchored wall, no, sometimes yung anchor niya, especially if you place your wall on the bodies of water, no, doon ina-anchor sa mismong ship na nakalagay doon. Pero, no, kung walang ship, no, therefore, baka walang anchor ang nilagay doon, no. Common lang nakikita ko dyan is yung si anchor, doon nilalagay siya mismo doon sa bodies of water and then it was anchored to a ship, no, abandoned ship, no. Pero andun pa yung malakas na strength din ni ship para tawag din to support the wall, no. So yun. So there are three conditions, no, that we need to consider. in designing earth pressure. The first one would be the at-rest pressure. Okay, so what is an at-rest pressure and what is the equations? What are the equations that we would consider in this at-rest pressure? Okay, the second one would be the active pressure. Okay, active pressure. What is the difference with the passive pressure? Okay, and what is the movement in active pressure and what is also the movement in passive pressure. Okay? So yun. Yun yung the three conditions you would consider. Okay. So these are the common effects or the common movement, no, when the three conditions occur. Okay? At rest, there is no movement. Okay? In active, there is a movement, no, pero yung kanyang movement, it is away from your soil, okay? Kumbaga, tinutulak ni soil, no? Tinutulak ni soil yung retaining wall natin, okay? And then, in passive, no? Si retaining wall naman ang tumutulak sa soil ninyo, okay? So, in at-rest pressure, no? Refer to the condition in which is prevented from lateral movement, okay, by the surroundings soil or by unyielding wall, okay? And it happen, no, if your wall, no, is static. Static means there is no movement, either it is on left or on or in your right, okay? And the soil mass, no, in a state of static equilibrium. Okay, so here are the common formulas that we are using, no, in solving the at-rest lateral pressure. Okay, so the first thing you have to do, no, in solving those lateral earth pressure, no, you have to draw first the lateral earth pressure diagram. Then after drawing the lateral earth pressure diagram, then go with these coefficients, no, coefficient of earth pressure wherein at rest. Okay, so the formula for the coefficient of at rest would be ko, K, which is the coefficient, and O, which is on original state, okay, is equal to 1 minus sine of your internal friction, okay? And then the lateral soil pressure, no, it is called as PO or just PO, no, is equal to your coefficient, okay, times the gamma and your height, okay? So yun. And then the resultant force, no, per unit length of wall, no, instead of PO na nakikita nyo dyan sa presentation, they use FO, should I say. Kasi, mas ma-determine mo, no, if it is a force by using F, no, force nga, no. So, baga mamaya, later on, no, magkaroon kayo ng tawag dito, misunderstanding about the PO, about the lateral soil pressure and the resultant force, no, if you are using both PO. Okay? So, the coefficients, no, of lateral air pressure at rest, no, kanina, we know about the 1 minus sine phi, which is introduced by Jackie in 1944. Okay, but no, there is additional thing from Sheriff Fang and Sheriff in 1984, no, wherein your Jackie formula, no, they add the value of your gamma, no, wherein the gamma dry divided by the minimum of your gamma dry minus 1. Okay, and then different naman kay Main and Colhay, no? Wherein yung in Jackie 1944, inad niya si over-consolidated clay, okay? Raised into sine phi, okay? But based on my experience, no, I didn't yet use these Sheriff Fang, no? And Main, no? Si Jackie 1944 yung mostly na ginagamit namin. Okay? So, yun. And then there is additional, no? Kapag yun ay densad, no? Compacted and backfill, no? Si Jackie, dinagdagan na naman no, ni gamma dry. And then, divided by gamma dry min minus 1. If you notice, no, it is the formula of sheriff, no? They just multiply 5.5. Okay? And then si Muin na naman, no, they introduce if your soil was over consolidated, no, the OCR, no, ni-raise nila ng sign and then fee prime, no, which is your fee, no, yun yung pagbabago ng delta ng fee, no, or the additional increase, no, in your fee. Okay? And then this one, no, by using your plasticity index. Okay? So, i-run through na lang natin yan. Huwag na natin intindihin gano'n. So, if you are getting the value of your coefficients of a lateral earth pressure, no, you can also check whether uh, nandito sa part na to, no? But if the layers of soil is not introduced or not placed, no, kung hindi naman sinabi yung name, no, therefore you cannot determine what type of soil it is, therefore you cannot check, no. So for the meantime, no, if your soil was a loose sand, no, it is from the range, no, from 0.45 to zero point 0.6. Okay, but if your soil is a dense, no, therefore, the range was from zero point 0.3 to zero point 0.5. Okay. And then in normally consolidated clay, no, the range is zero point 0.5 to zero point 0.7. And in over consolidated clay, no, it is from 1.0 to 4.0. Okay. And for compacted clay, no, it is zero point 0.7 to 2. No. So the coefficients of lateral pressure has no unit for it. Okay? So yan. This is a typical value for KO, or this is the diagram for a typical, no, for a one layer of soil. Okay? So the force, no, the force per unit length of wall, no, instead of PO, kaya nga sabi ko kanina, instead of your PO, you have to place it with FO. Wherein you can get by 1/2 the gamma H KO squared, no. 1/2 KO gamma H squared, no. Saan natin nakuha itong si 1/2 KO gamma H squared, no? It is just simply the area, no, of your diagram, okay? It is 1/2 base times your height, okay? So, height mo, yun yung taas ni retaining wall, no? Or yung lalim ni retaining wall, no? And then your base, no, it would be KO gamma H, okay? So, ganyan lang yung kanyang tawag dito, ganyan yung kanyang formula when you are getting the area, no, or when you getting the height, no, doon sa bottom part, okay? And then in determining the resultant, no, or the location of the resultant force, no, just multiply h just tawag dito, just multiply h over 3, no, wherein h over 3, it is just your centroid, no, of your triangle measuring at the bottom of your soil. Okay, so the reference would be at the bottom of your soil. Okay, especially if you are given with more than 3 layers of soil, no, therefore the best thing to do is to place your origin, no, at the bottom, no, instead of at the top, kasi nga baka mamaya ay maguluhan kayo because of so many things to do, no, kasi if there is a more than 3 layers of soils, no, therefore, lahat ng mga soils at the bottom would transfer at the top, no? So, mas mahirap yun, no? Compared to a thing na kapag ang reference nyo is at the bottom of your soil. Okay? So, yun. So if the layer of soil is more than one, no, or it is two, no, for this type, no, it is a two-layer soil, no, and then the first layer would be the unsaturated or the dry, no, soil, and the second layer would be the saturated, wherein your soil was placed, no, at the bottom of the groundwater table. Okay, so the first or the diagram at the top of your soil would be similar to the first kanina, the first figure, which is a simply a triangle, no? And then to get the diagram at the bottom, no, the first part, no, would be the bottom of your the triangle, wherein i-move mo lang, no, at the bottom, no, until to the bottom of your soil, no, yung value ni first layer of soil for the second layer, no, and then the second part for the second layer, no, the effect of your saturated, no, therefore there is another KO gamma H, no? But KO, no, if you have a same value for internal friction, therefore it is only one na KO, no? But if you have different value for internal friction, therefore there is two different KO, okay? And then the thing you have to do, you know, yung gamma H, okay? And then, so since there is a water table, no, you have to separate the effect of your water table, okay? Or you have to separate the diagram for the water table. No, it is just simply a triangle, okay? So yun. But no, in determining the value of the water table, no, it is just simply the gamma times your height. Okay? So yun. I think wala naman na ako nakalimutan. Okay. So summing all those values, no, ganito yung mangyayari, no, sa baba, no? So there is a additional effect. So this is only applicable if your soil has no additional surcharge or there is no cohesion. If your cohesion is zero, okay? What if there is a additional cohesion or there is a surcharge? Later on, we have an example for it, then we would be able to understand. Okay? The next one, ayan. Dito muna tayo kay at rest lateral earth pressure. So, we will take another example for it. Okay? So, the first example, no, I think na si Miss Palogan can read it. Miss Palogan, please read it.
A retaining structure is supporting a 6 meter high excavation as shown in figure 1. The wall is very rigid so that the soil behind the wall is in at rest condition. Sketch lateral earth pressure diagram. Determine the lateral earth pressure at rest PO. Determine the hydrostatic force PW.
Okay. So for these examples, no, um, hindi na natin babaguhin si lateral earth pressure, which is PO. Dito na lang tayo kay hydrostatic force. No? It is a force, therefore, F na lang nilagay natin mamaya. Okay? So we are given with two types of, dito na lang tayo kay paint. Nilipat ko na ata kay paint. Yeah. So we are given with a two layers of soil, no, with different types of soil. No, the first layer would be this fill sand with a internal friction of 25 degrees. The cohesion is zero, and the gamma drive, which is 18 kilonewton. No, at the bottom of your fill sand, 3.5 meters. No, there is a presence of your groundwater table, no? Therefore, it is silt, okay? So the value for your internal friction, which is the same, which is 25 degrees, the cohesion is equal to zero, and the saturated unit weight, which is 20 kilonewton per cubic meter with a height of 2.5 meter. Okay? The first thing we have to do is to determine, no, yung kanyang diagram. Okay? Yung diagram niya. Okay? So, yun. Let's draw yung kanyang diagram. Paano ba? Sige. Okay. So, yeah. Let's draw muna. Yun nga, for the first layer, no, we have to draw lang yung simple triangle. Okay. So that is a diagram for the first layer, okay? For the second layer of soil, no, yun yung sabi ko kanina, if there is no effect or there is no cohesion and there is no another surcharge, therefore same lang yung uh, number 2, okay? Same lang yung number 2. Okay. Sorry kung medyo kita. Ganyan na lang. So, ganyan yung kanyang gano'n. And then, because it is a saturated weight, no, there is additional effect wherein there is a additional triangle for it. Okay, and then it was subjected for the groundwater table. Therefore, you have to separate the effect of your groundwater table. Okay, so like that. So like that. Okay, so yun. And then, kunin na lang natin yung value later on ni mga ito, the here part, no? And then this part, and then this part. Okay? So, yun. Tapos na tayo sa first part, which is the drawing the diagram of the lateral earth pressure. Okay? Therefore, punta na tayo kay second part to determine the layer, to determine the lateral earth pressure wherein at rest, no? PO. Okay? PO. Okay, PO. Okay? Wait, kunin ko lang yung calculator. Okay. So, yun. So, in determining the PO, it is just PO, no? This PO is equal to the PO gamma H. No, gamma H. Okay? And then, kunin muna natin si KO. Since we have a gamma and then there is a H. Okay? Since the two layer soil, no, the two different soil has the same value for your internal friction. Therefore, there is a common KO or there is a common coefficient of your lateral earth pressure. Okay, so KO is equal to your value 1 minus sine of phi. Okay, for instance, we will put O, no. Therefore, it is 1 minus sine of your phi, which is sine 25. Okay. Therefore, the value for it is Wala ka. Wait lang, sinisave. Tagal mag-save ha. Ganyan. Ayun, nawala nga. Okay. EO is equal to 1 minus sine, bro, EO, gamma, H. Okay. For KO is equal to 1 minus sine of your phi. Therefore, equal siya sa 1 minus sine 25 degrees. Okay, what is the value of your KO? What is your value?
0.577.
570. 577.
0.577 ah,
38.
38. Okay, so yan. Okay na yan. And then, sabi ko nga, there is no unit for the KO. Okay? So, punta na tayo kay PO. Okay? So, in determining the PO, no, we have to separate it by layer. Okay? So, at the first layer or at height, at, okay, at age is equal to 3.5. Okay? Meters. Therefore, si PO mo equal siya kay KO gamma H. So, your KO would be 0.57738 times your gamma, which is 18 kilonewton, okay? And then your age, which is 3.5. Okay? Therefore, the value of your PO at the top layer, which is
36.37494.
36.3749. Same lang po sa nakuha ng iba? Same lang?
Yes, sir.
Yes, sir.
Okay. And what is the unit for it? Your gamma 8 is kilonewton per cubic meter and times to the height, no, which is meter. Therefore, the unit is equal to
Kilonewton per
Kilonewton per meter.
kilonewton meter per meter square is equal to ano yung kilonewton per meter square?
Kilopascal, sir.
Kilopascal.
Are you sure? Are you
Pascal.
sure with the kilopascal? Are you sure with the kilopascal?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Kilopascal. So that would be the pressure or the lateral earth pressure, no, at the top of your soil, okay? Or at the first layer of your soil, no? So at the bottom na pa tayo sa second layer, which is at height of 6 meters, okay? 6 meters. So PO, no? For the first part, no, or to yung sa square, no, which is equal lang sa 36.3749. Okay? Wala namang pagbabago dyan. Okay? But dito lang tayo kay another triangle which is PO equal to your KO times your gamma H. Okay? In your KO which is 0.57738. Okay? Multiply it by the value of no your gamma which is 20. Take note it is a saturated, no, therefore bawasan mo ng gamma of water, no, or gawin mo siyang submerge, no, or effective stress, no, wherein 20 minus 9.81, no, times your height which is 2.5. Okay, therefore the value for it is equal to ano value niya.
14.708.
About the others, same lang ba, no? 14 point, ano yun ulit?
708. 7.
70858.
7, 8. 757.
78.
5, sir. 75.
So, yun. In kilo Pascal. Okay? That is the value at the second layer. No? Pero take note, there is another, no, value for the groundwater table. Here. Andito part. Okay? This part. Okay? Yung 14.70875, this would be for this part only. Okay? And then this part, no, it is just the same at the top. Okay? So, yun. So, punta na tayo kay out water. So, at water, no, PO mo, sabi ko nga kanina, it is just the gamma times your height. Okay? Wherein the gamma of your water, which is 9.81, and the height of your water is 2.5. Okay? The value is, the value niya,
24.525.
24.525 kilo. Okay? So that is the lateral earth pressure when it is at rest. Okay? Yan yung values ni lateral earth pressure kapag siya ay at rest. Okay? Ganun lang natin. Yan. So, punta na tayo kay hydrostatic force. Okay? Paano ba natin ma-determine si hydrostatic force? Okay? It is just simply the area, no? Wherein FA, hydrostatic force. No? FO, should I say. It is at rest. Okay? FO, no? It is equal to the area 1, no? Area 1 plus area 2 plus area 3 plus area 4 because you have four different diagrams. Okay? So for FO in area 1, no? Area 1, it is just 1/2 base times height, no? The height is equal to 3.5 and your base would be the value of your PO1 which is 36.3749. Okay? So, yun, it is just 1/2. Your base would be 36.8749, okay, times your height which is 3.5. Okay. So at the bottom layer, no, dito na tayo kay area 2 which is this part, no. Later on, ilagay ko na lang si 1, 2, 3, 4 para hindi kayo para hindi niyo ah, malimutan. Okay? So for this second layer, it is just the length times your width, no? Your length, no, would be the tawag dito at the bottom layer, no? Yung value niya ito, which is your 36.3749. And your width would be the height, no? Which is 2.5. Okay? So, yun. So, 3.5 plus your length, which is 36.3749, no? Times the value of your height, which is 3.5. Okay? No, 2.5 should I say. And then at the third layer, no, same kanina, which is your base times height, 1/2 base times height. Your base would be the 14.70875 and your height would be 2.5. Okay? And the same later on sa water. Okay? Wherein sa water, no, it is a 24.525. Your base and your height would be 2.5. Okay? So therefore, 1/2 times your base would be ano yung base natin kanina? 14.70875. Okay? Multiply it by your height, which is 2.5. Okay? And then add na natin si water, which is 1/2 your base of your base, which is 24.525, and your height would be 2.5. Therefore, the value of your FO, CFO, equal to, ano CFO?
203.6355, sir.
203.6355. Okay? And what is the value? Take note, it is kilonewton, no? Your PO, it is kilonewton per meter squared times the height, which is meter. No? Therefore, it is in kilonewton per meter. Tama ba? Sakto lang?
Yes, sir.
So, this would be your value for FO, no? For your ganyan. So, yan. Diyan lang yung kanyang value. Okay? So, yan yung kanyang ganun. And then for your example number 2, later on, nandun sa PowerPoint, no? It is just simply the same. No? Same lang siya. Save ko lang baka mamaya ma-delete natin. So, yun. So, this is your example number 2, no? The same lang siya, no? There is no cohesion, no? And then there is no additional surcharge. The only difference is your unit weight, no? Which is your unit, no? Which is in English, no? Pound per feet cube. Okay? So, yan. So, in calculate the lateral force, your FO, no? And determine the location, no? So, later on, ibigay ko na lang yan. Okay? So, for this moment, no, we would be able to determine also for the active lateral earth pressure. Okay? So, it happens, no, if the wall moves away from the soil, no? The soil tends to experience shear failure, which resulted a sliding soil wedge that move forward and backward. Okay? So, for this type, no, it is just, no, tension, no? Kasi nga, sabi niya, move away from the soil, no? It is a tension, no? Tinutulak ngayon ni soil si wall na nilagay natin. Therefore, no, mas malakas yung force ni soil, no, compared to the force of your wall. Okay? Yun. And then the earth pressure exerted on the wall at this state of failure is known as the active earth pressure, PA, no? And there are several methods that can be used to calculate whether it is active or passive lateral earth pressure, no? The first approach would be the Rankine's approach. The second approach would be the Coulomb's approach, and the third approach would be your Coleman's method, no? So, for this approach, no, or for these methods, no, um, ang pinakasikat, no, it is a Rankine, no? And then, next lang si Columns, no, ang pagkakaiba na lang ni Columns, no, they just add a additional uh, frictions or additional angles, no, just like your beta, your omega, and your alpha, no. And columnance, it is just the same to your columns, no, approach. Okay, but in your review later on, no, and then in your board exam, no, it depends if, no, dito sa dalawa, which is the Rankine's approach and the columns approach. Okay? So, yan. Diyan lang sa dalawa naman. And then, ang most sikat nga, sabi ko, it is the Rankine's approach. Okay? So, yun. So, kanina, si active pressure, it is the effect, no? It is just the tension, no? Wherein the soil moves the retaining wall, no, away from it. Okay? But for this passive pressure, no, it is a tawag dito, it is just a reciprocal or the opposite of your active, no. Yun nga, kapag may negative, may positive, like that, no. So for passive, no, it is happens if the wall moves toward to the soil, no, uh, it is just simply as the compression, no? It is simply as your compression. Okay? And then the soil tends to experience shear failure, which resulted a sliding, no, soil wedge that moves backward, no, from your retaining wall and upward from the original. Okay? And the earth pressure exerted on the wall at this state of failure is known as your passive passive earth pressure or PP. Okay? And then there is a coefficient of passive earth pressure, which is Kp for passive, no. But for active, no, it is just a Ka. Okay? And then the resultant force per unit length of your wall, no, for active, no, gaya nga ng ginawa natin kanina, for the attress, no, it is force, no, therefore it is Fo, no. For passive, it is F P, no, and for active it is FA, no. For the value or the formula for that, no, for active it is just 1/2, no, Ka times your gamma H squared. And then for passive, no, the K either replace it with your Kp. Okay? So yun. So this is the common type, no, for Rankine's active pressure, no, when there is a additional cohesion for it, no. So ano yung nagiging mode of failure niya or kung ano yung diagram niya, okay? Because of the cohesion, there is another effect on the other sides with the contact of your soil, no, doon sa mismong contact ni soil, no, to your retaining wall, which is your, if it is active, no, it is minus 2c squared of your Ka. But if it is passive, no, it is positive 2 square root of Kp. Okay? Meron yan later on. Okay? Ito na. So for Rankine's theory, we assume it as no friction between your wall and your soil. Okay? And the coefficient of your earth pressure, which is a active, no, Ka. Okay, so the coefficient would be equal to 1 minus sine phi at the numerator, and at the denominator would be the 1 plus sine phi. Okay, so yun yung mostly na nagagamit, si 1 minus sine phi over 1 plus sine phi. Okay, so what happens if the um, the soil was placed on a backfill, no, horizontal backfill, no, wherein yung Ka mo mag-iiba, which is tan squared, no, times 45 minus phi over 2, no? But another, kapag ito ay nasa sloping backfill, no, so therefore there is a beta, or there is a angle for it, no, for the sloping part. Okay, and then it was from Ka, no, cosine beta times the quantity of cosine beta minus square root of cosine squared beta minus cosine squared beta divided by cosine beta plus the quantity of square root of cosine squared beta minus cosine squared beta. So as you can see, no, the difference for the upper layer to the low, for the numerator to the denominator, it is just the sign convention between it, no. For the active, no, the numerator would be negative, no, and then for the um denominator would be plus sign. Okay, so yun yung kanyang theory for active. Okay, and then that is the lateral soil pressure and the resultant force. So laging inuulit yung kanyang mga formulas, okay? But for the coefficients of passive, no, earth pressure, no, it is yun nga ang kinaibahan niya kay active, no, the numerator would be the positive and the denominator would be negative for passive, okay? So simply as, no, it if you like to determine, no, it is just the inverse, no, of your, the passive is the inverse of your active. Okay, so kabaliktaran lang ni active. So to get it, no, Kp, it is equal to 1 over Ka. Okay, so yun, and then like that's one, no. So what happened if there is a cohesive soil, no? So the lateral soil pressure, no, phi may increase, no? Yun nga, increase kapag passive and decrease for active, okay? The effect of your 2c square root of, if it is active, Ka, therefore it is minus, and then in passive, no, Kp, it is plus, okay? So for multi-layer of soil, no, if extra surcharge imposed on the top of your soil, no, not only for the cohesion, no, the lateral soil pressure fee will increase, and it's depend to the surcharge value. Okay, and it is only applicable, no, if imposed by ultimate dead load, no, and point load, no. If the groundwater table encounter in soil, no, therefore your lateral earth pressure, no, will increase. Okay, and the value may be determined by using, no, the following equation, which is your gamma h and then 1/2 gamma h squared, okay, for your force. Okay, so yan, this is the second one, which is the columns earth pressure, no, the second method, no. Before, yung kanina si active and passive use Rankines, no. For this time it is a columns, no. So the coefficient of your columns earth pressure, no, would be equal to sine squared times your alpha, no, there is additional angle, plus by the quantity of sine squared alpha times sine alpha minus your beta, no, or your omega, no, whatever the question is giving you, no. times 1 plus squared ni sine alpha, ni phi plus your omega times sine phi minus beta, no? Divided by sine alpha minus phi, sine alpha minus your omega, and then sine alpha plus your beta. Okay, and it is n squared. Okay, and then the same lang yung kanyang uh, force, no? For normal component, no, you multiply just the cosine omega. Okay, so that is the example of a retaining wall in terms of a columns method. Okay, ayun na nga, meron na si beta at the top, no? The effect or the change of your soil because of the effect of your retaining wall, no, with respect to your soil. Okay, and then there is a value of your alpha at the bottom layer of your um bottom part of your retaining wall. Okay, so yun. And then if your beta is equal to your omega or equal to zero, therefore your alpha would be 90 degrees, okay? Or it is in vertical, no? So therefore, same lang yung kanyang KA, no? And ang pinagkaiba niya lang, no? The N, multiply by it and phi, no? And N phi, no? It is equal to tan squared 45 plus your phi over 2, okay? But for tawag dito, educational purposes, no? Yung sa columns law, we will just apply this formula, yung kanina. This one, yung sa first part, no? Yung sa KA, no? Ito yung ganyan. Okay? And then for passive, no? There is a difference, no? Doon sa active, no? Tignan natin yung difference ni active, which is A minus ganun, alpha minus omega, and then plus and minus, okay? Pero sa passive, no, it is the same, no? Plus yung lahat ng ganun niya except for the upper part wherein it is a tawag dito, it is a minus, no? Parang bumaliktad lang, no? But for the second quantity, which is yung may square root, no? As you can see, all of them are positive. Not compared to your active, no? One part, no, of your square root, no, at the numerator isa yung negative, at the denominator isa yung minus sign. Okay, so yun, and this would be your Rankine's passive pressure. Yun nga sabi ko kanina, in getting the Rankine's coefficient of Rankine's passive, no, with the relation of your active, no, therefore 1 over your Ka, or it is just a inverse value of your Ka. Okay, and what is the theory of your column? Okay, for columns theory, assume that the failure occurs in the form of a wedge. Okay, and assume frictions occur between your wall and your soil. Okay, and then apply for cohesionless soil, and then coefficient of your active pressure Ke, and then your resultant force. Okay, so yun, it is just a simply kapag active siya, Fa, and then kapag passive, Fp. Okay, it is important to use all those subscript like O, A, and P, no? So that you can determine whether it is a active, passive, or a tawag dito, or in a original state or in at rest. Okay? So yun. So before we go to your to our um tawag dito, to our examples, no, we shall have a short break, no, para naman makapag-almusal na kayo, or sa to attend some necessities, no. So we will have a short break, 15 minutes break, therefore we will be back at exactly since it 8:57, so we will make it as 9. Therefore, we will back at 9:15 a.m. Okay? We will back at 9:15 a.m. Okay lang? Okay. Sige, attend to your necessities for